Welcome there, function folks. We're on lesson 3.10. Trig properties is what the name of the lesson is. I wish I could say that we're on the home stretch as far as trig is concerned, but we've got quite a few bits of business to deal with still. So let's get into today's stuff. Now today, hopefully, you've done a couple of things because you're watching this video. You've done this big long 3-minute review, which will take about 10 minutes or so, as well as a sheet that looks like not that, looks like this. So hopefully you gave that a go. In this video that you're watching, I'm going to take up, hopefully fairly quickly, because the extensive answers are actually included with the 3-minute review. So I'm going to try and just explain that quickly. But then I'm going to also maybe give you hints about this sheet if you haven't tried that sheet or you got stuck on it. I'm going to give you some hints. And then in the second part, I'm going to take up this sheet and show you my answers. And we'll go through some examples of this types of things that are going to be in the homework for today's stuff. So that's the plan. The first one is basically some interpretation. How far is the pendulum from rest after 4 seconds? How far is the pendulum from rest? That's just d at 4, right? So all I have to do is calculate d at 4 and then bash that into a calculator. One mention is be careful that you put the pi times 4 in brackets. But, you know, this 4 seconds here, sine of 4 pi, if we think of the rotation angle, 4 pi, there's 2 pi, there's 4 pi. Sine of 4 pi is going to be where that terminal angle crosses the unit circle. That's supposed to be a unit circle, not very good, I realize, but remember the coordinates are 0, 1. This is the cosine of that rotation angle, and there's the sine. So this is 0, and that's where the answer gets. So what does that mean? It means that the pendulum that's going back and forth has returned to the resting position. So that's it. The IROC at that is whatever. What does this mean? Well, the answer says the distance from rest is decreasing. Decreasing because it's changing, and decreasing because it's a negative, right? Since the IROC is negative, we know it's decreasing. So that also means it's moving towards rest, right? It means it's moving back towards, it's moving left. Moving left. And part C, if you just read this, if it's the IROC at 8.5 seconds is 0 centimeters per second, you calculate that. What does that mean? If the rate of change is 0, it means it's at a maximum or minimum, right? So this is some sort of sine function, right? It's going back and forth. The pendulum goes right, left, and so on. It's either here or here. And actually, we talked about early on in rate of change, we could decide whether this is a maximum or minimum by checking the preceding interval to 8.5 and the following interval to see whether it's, the IROC is positive, 0, negative, right, which would be positive, 0, negative, show a maximum, or negative, 0, positive. Negative, 0, positive would show a minimum. But we're not worried about that. We were just asked to interpret it. So let's just erase that. Dandy. Hopefully you're okay with that. Don't be afraid to ask about these stuff in class if my video explanation is a little bit short, because I know you want to get on to the lesson so you can get on to the homework, so you can get on to whatever else you want to do with your day. Sketch the graph for these values. And notice that if you're asked to graph a certain amount, we're used to bing, 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 important point, bing, 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 important point, bing, 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 important point, like this. This is what we're used to, right? If you're asked for a specific domain, one thing you could do is graph it normal and then just ensure that you have this batch, right? Well, where is that? What chunk of the graph is this? This is between pi over 3. Remember, each tick was pi over 6, so there's pi over 3. Where's 4 pi over 3? Well, 4 pi over 3, if I change that to pi over 6s so I can figure out how many ticks that is, equivalent fraction, 8 ticks. So 1, 2, 3, 4, 5, 6, 7, 8. That's to there. There's 4 pi over 3. So as long as you ensure that you have your graph in between that much, you've got it. And no period change, so this one should be okay. What's this? This is left a certain amount. Left how much? Well, 3 pi over 4. How would we figure out how much 3 pi over 4 is? Well, the way that I would think of it, and I'm making a mess here, but that's okay. Pi over 4 is 1.5 ticks, right? So then 3 pi over 4 is that times 3. It's 4.5 ticks. So I'm going to move my normal sine function left 4.5 ticks. And if you, there's 3, 4.5, and then you could fix it up. Like I said, I'm doing a quick job of it. And there's my graphing calculator version. And notice that I put in my window settings, that's negative pi over 2. This looks like it's more than, this is more than pi, but less than 2 pi. This might be 3 pi over 2 or something like that. I'm not sure. And notice my scale there, all that. And then I drew that graph, and I've got the tangent on from later questions as well. So hopefully that's okay. So don't get thrown off by being asked to draw a graph with a certain domain. If we do our normal one and extend it, or just make sure that we have that much, we're good. Draw the secant from pi over 2 to 3 pi over 4. Well, I'm going to go to my original, or sorry, my answer, pi over 3, pi over 2 to 3 pi over 4, pi over 2 to 3, where's 3 pi over 4? Well, 3 pi over 4 is that, there's pi over 4, 2 pi over 4, there's 3 pi over 4. And actually, this is pretty close, kind of sloppy. Maybe this was the tangent. Maybe that was the tangent that I drew there. And then what is, or sorry, the secant. And then this, we have to find the slope of the secant. Okay, so that was in the answer the secant, because it didn't ask me to draw the graph of the tangent. Okay, I'm caught up with you now. So this is the secant from pi over 2 to 3 pi over 4. This is 3 pi over 4 here. And that's the secant. You calculate the slope, and it says in the answers, if you just calculate the slope, remember, I need some room here to explain. Find the slope of the secant. Well, remember, the A rock is just y2 minus y1 over x2 minus x1, where this is function values, right? I could just jam pi over 2 into this and pound it into a calculator. And that's what the answers suggested you do. However, the answers also said decimals would be fine, but smiley face. So something might be going on here. Well, these are exact values, right? So have a look at this, that I could have used AROC and exact values, right? So 3 pi over 4, and this got cut off. Is take out the x, put in the 3 pi over 4, then I have the sine of 6 pi over 4, and this is exact values. What's the sine of 3 pi over 2? Well, the sine of 3 pi over 2 is this rotation angle, and if I think of this as the unit circle, where does this cross the unit circle? Well, at the point 0, -1, that's the cosine, right? That's the cos of 3 pi over 2. And this is the sine of 3 pi over 2, right? So that's where that -1 came in. And so I can get that value exact. There's that value exact. Another calculation gives me the exact value of 5 pi over 4. So where's that one? 5 pi over 4, this would be 4 pi over 4 is the same as pi. 5 pi over 4 is over there. And I can think of what this exact ratio would be. Well, it's going to be -1 over the square root of 2. How did I know that? Well, I know from my chart that the raw is pi over 4, and so the sine of pi over 4, I look it up on my chart, is 1 over the square root of 2. So the sine of 5 pi over 4 is going to be the same number, but maybe negative. And when I think of the cast rule, yeah, only this tangent is positive in this quadrant, so certainly it's negative 1 over the square root of 2. And then I do that calculation, I can actually clean it up, multiply by a convenient form of 1, and I get that 2 pi over 2. And isn't this fun? That's exact. We love being exact. On the bottom, x2 minus x1 is just an exact thing, a little bit of arithmetic here, and isn't this awesome? There's the exact answer. Would I expect you to do that? If you did something, if you did something like that on a test, I might give you a bonus mark for that, because that is beautiful. Beautiful. Also maybe takes you a few more seconds, but you know me, I'm all thumbs with my calculator, so I'd rather use my brain and a couple of diagrams. You wouldn't have to necessarily do that. The IROC, 2.91 about, and how would you get that? This time you've got to use decimals. Essentially, remember, the IROC is still just f at x plus h minus f at x over h, where the h is something that we want to have very close, right? Very small. H is 0.01. Our x was, where were we trying to find our tangent again? Pi over 2. Pi over 2. Certainly we can see that the tangent would be positive, right? The slope of the tangent would be positive. And then our pi over 2. And so we'd actually have to crank out our calculator, get our calculator, and put in the decimals. And I'm not using 3.14. I have to use my pi key. That one maybe I could do exact. This one I'd need decimals. And I get around that 2.91 that was in the answers. All right, what's left? Oh, the discussion about even and odd. Well, back when we first talked about even and odd functions, way back in Unit 1, we said the sine function was a great example of a function that was odd, because when I flip it this way, and then flip it the other way, I end up with the same graph back, right? So this is odd. And in fact, that gives us this little rule. And the idea of when I flip it in the direction of x and then the direction of y, direction of x and direction of y, I get the original graph back, right? That's what odd means. Similarly, cosine is even because when I flip it this way, right? It's even because when I flip it over the in the direction of x over the y-axis, it's symmetric. So I know cos of x equals cos of minus x. How could you show or prove this? How do you know? Well, we know it graphically, but are we sure about that? Or does it just look close? Because we saw other graphs that looked pretty close to even or odd, but weren't. How could you show or prove this? This is today's stuff. Today we're worried about this. Okay? One thing that you might think about doing is trying some values. So put in some values for x, like put in pi over 2. Sine of pi over 2 is whatever it is. It's 1, right? It's positive 1. Then if I type in the sine of negative pi over 2, do I get positive 1? Well, yeah, I do. But I'd have to check every possible value of x to see if this is true. There's some way that we need to show and prove that, and that's what we're up to today. So what are we doing? We are doing this sheet, and hopefully you've got this filled out. And the idea is, this is a little bit of business about the unit circle. So this first part is just a little reminder. Remember that when I've got a terminal arm that cuts the unit circle, the first coordinate is the cosine and the second coordinate is the sine. This is reminding you of this. So sine is y, cos is x, and then you can fill in the rest. The rest of the diagram refers to this thing, and it's pretty confusing, but hopefully if you go slow and walk yourself through it, it'll be okay. Remember, this is a setup step here. that the cos of theta here then, theta is, this is the sine of theta, or cos of theta is the x coordinate. The sine of theta is the y coordinate, and so this is b, and this is a, and the tan then, remember that little trig function, is b over a. Okay, and this is just getting us going. Now, how does the rest of this work? Where's DOC? I'm going to erase this and start talking about where's DOC. DOC is this one. Well, that's just 90 degrees. DOC is pi over 2 in radians. So what's BOC? This angle here. BOC, this angle, well, it would be 90 minus this theta. Right? Or pi over 2 minus this theta. And then it walks you through, bit by bit, this sheet to try and find the cosine and sine of these different angles. These are called cofunction angles. So for instance, because this point is where the angle 90 minus theta, or pi over 2 minus theta, meets the unit circle, this is the cosine of pi over 2 minus theta, right? Because it's the x-coordinate. The y-coordinate is the sine of pi over 2 minus theta. All right, now you try and fill out the rest of the sheet. We will take it up at the beginning of part 2.